going to pair program with some people from Vitovi on how to make a list performance rendering faster, live list performance rendering. So here I've got to do MVC, and I'm going to add 10 to-dos, and you can see that went pretty fast in Chrome. And now I'm going to bump it up to try to render 100 to-dos, and you'll see that, well, you might not be able to notice the timing difference, but it'll actually take more than, when I hit this button, you'll see this number down here is actually slowing down. That's because as we add more to-dos to do MVC, the rendering gets slower and slower because we're ending up right now rewriting the entire list of to-dos when you add one to-do. This is because the to-dos that are being shown is a filtered list, so it's being recalculated every time. We want to avoid that cost, so we're going to diff in our lists. And the code that manages a live list is in CanView Live here. This is past a compute that represents the list, and then it listens when any item is added to the list or removed from the list, and adds or removes elements accordingly. What it doesn't do currently is if the list itself is changed, well, it just redraws the entire list of elements. What we want to do is make it so if you had a list like, get out of here, I'll make you go in the background. Okay. If we had a list like with item 1, 2, 3, and then eventually you replace it with a brand new list that had 1, 2, 3, 4, I want to make this live binding smart enough to recognize that 4 was added and just add 4 instead of updating every element in the list. So the first thing is I kind of already started putting this console log, and I want to find out why the heck that's not showing up. Make sure that I'm actually working in the right place and got everything saved and loaded. So let me open that up. Make sure that that is actually list. Oh, CanView Live. Okay, so it's got the console log. It's possible that I might, interesting. Okay. Something is going wrong that I don't understand. Let's check the actual application logic of this to-do MVC and make sure it's working the way that I expected it to work, especially its template. It should be going through each display list. That's what I expected. I'm not sure why it's not calling the each helper. Let's put a console log in here. Okay, so something is, I wonder if, this is very confusing. I wonder if he's not actually using CanJS. No, he's using CanJS. Why is this never getting called? This is very confusing to me. Let's even back out even more. See if this module is even the right module. So apparently it is. Why each is never getting called? That is confusing. The only thing I can think is that stash helpers aren't working right, or something even weirder is happening. So here's the each. Hopefully this gets called. This is getting called. Resolved is, looks like a normal array here. That's confusing. And that makes sense why each is not called. Oh, I think I know what might be the problem. I'm kind of confused. Filter, let me make sure here. Filter should be turning a list, not an array. If that's true, then we've got a bug in can.js. What am I doing here? I'm not used to using Firefox.
Mom, what are you making?
Hello, Kyle. All right, and we will go and check. Okay, so this is a bug. So I think they overwrote the normal to-do list filter to use an array instead of a list. So that's a bug in this implementation of I don't know what this is. I'm gonna find where that is. That is in todo.js. We gotta get rid of this filter. There. Now let's try. Okay, so in that case, the Ilya, by the way, stop me if you have any questions at any time.
Sure.
That shouldn't be using live binding, because there's really nothing to live bind to. If you know what I mean, like we could actually make this same logic work if someone passes it a normal array, but that's not what I'm really focused on right now, because it's just most things are always observable lists that people pass around. So this should now hit that filter, which should use a normal can list. Now each should be resolved to a instance of can list. Yep, and now our console logs should be hit. Okay, so that took a while. I should delete all of that from the thing. Now, what is going on here? Okay, so there is no old list. That's why it's complaining. Get rid of some of these console logs here. Okay. Now, I'm doing like debugger too. Okay, so now when I hit this, you can see it grows. Okay, so now we finally got a place where we can work from. What I think I'm gonna do is my approach for this is I'm gonna just try to get it working in the To Do MVC app. Then I'm gonna write a test for it, and then I'm gonna hopefully be able to commit it and kind of review it and make sure it works. So let's look at live. So one thing I need or I want is an ability to merge, to kind of see a delta easily. Or to do a diff on two lists. Ilya, do you have a question or?
No. I was just asking somebody to join this because I have to leave like in half an hour.
Okay. Okay, cool, yeah. Okay. So the first thing that we really need is the ability to do a is the ability to do a diff of two lists. So what I want to do, I'm not even going to start with like worrying about the DOM. What I really want to do is just say, hey, given these two array-like structures, give me a list of changes that need to be made to go from one to the other, if that makes sense.
Yeah. Mm-hmm.
So fortunately, in Can Connect, I actually kind of started a mini array diff that I'm just going to reuse its code and probably build eventually a better version of. Helpers, I think I called it merge, ID merge. We're just going to copy this code and we're going to bring it into can util. And we're going to call it diff. We're going to modify this a little bit. So we're going to use some of the similar code. So what we really want is a function that takes a list, an old list, which is list in here, and a new list. And it also is going to take it needs a way to identify what, like a unique, like what, some way of being able to identify what, like a unique ID, so that we can compare one object to another, be able to know, like, is this object the same as this other object without you having to like do triple equal. You know what I mean? Like, so we can have a hash map if we have to.
Justin, so if an element of an array is an object, do we and we are comparing two arrays? So do we say that? So we don't do deep equality of the objects.
Yeah. We're not going to do. No, we only want to see if like they're the same object in memory.
They're the same. Okay. Mm-hmm.
So actually, with this algorithm, we might even be able to. We might not actually need that way to get what is a unique. Really, what you want in JavaScript, which would be amazing if JavaScript had this, is to somehow get like the actual pointer value for different objects. So I could say like, what is the actual pointer value, memory address value for this object, right? But you can't do that in JavaScript. So every observable in CanJS has a CID, which is kind of like a, client ID, which is kind of a unique ID for every object, and we can compare those.
Mm-hmm.
But I don't know if we actually need to do that for this version of the algorithm. For more complex versions, you will need to do that. So I'm going to leave room for passing what that unique identifying property, like for passing a function that is the unique identifying property. But actually, I'm probably going to make it so it works without that at first. So anyways, we'll do it without it for now. We'll just default to using CID everywhere, but we can change that eventually if we need to. So what that's going to do, what we need this to do is return the splices that we're going to want this to return some data structure like that is an array of essentially stuff that you would need to splice. So maybe you might, if you were inserting one item at position 0, maybe it's an array of arrays that represents the call to splice you'd have to make, which it might be like 0, position 1, you're removing one item, and then maybe at another position you're inserting one item, and you're inserting A or something like that. Does that make sense?
Yes. Yeah. Mm-hmm.
This is going to return essentially what's called the patch.
Okay. Mm-hmm.
All right, so this is going to do a diff and return a patch, and then we'll use that information to do the right things. Live will use that information to do the right things. Okay, so okay, so let's go through what this algorithm already does. This handles single insertion or removals. So all it does is it looks if it just starts iterating through the list or the new items and just checks if they're if they're the same, if each item in the list is the same, then it just moves to the next item. And then it looks like if the next item in the new list matches the current item, that means you've the current item in the old list, that means you've inserted something.
Mm-hmm.
Right? It means like if this was the old one and the next one is equal to, is the next position, if you were kind of on comparing these two and they weren't equal, but if these two were equal, that means you've inserted something here.
Mm-hmm.
So then this will actually, this version of this that I made actually just does the splice, but we're not going to do that. We're going to instead add that to the patch. Otherwise, it also does the same kind of thing in like if you were in another situation where you had 1, 2, 3, then you had 1, 3. So if the old one looked like this, so if you're comparing these two, but the next one here is matching, that means you've removed something.
Mm-hmm.
So that is a splice remove. And then finally, if you don't have that, then that means you essentially are just going to what we do is just say, okay, just clear out everything else. You're going to set everything past this point to look like the new version. That's what this does. So this isn't a very good algorithm. It's the first one I wrote just to solve like the most common case where you have a single insertion and removal. And later, hopefully, people can go back and improve this to handle more varied cases, especially the case where you're adding multiple items at once. That's something that we definitely want to be able to add at some point, if that makes sense. That would be like the first improvement that I would make. Okay. So I'm just going to copy this, but I'm going to change list in here to old list. And I'm going to change update to new list. And then I'm just going to copy this. Code. And I should write tests for this. My other thing actually does have tests for it, so maybe I might actually create a diff test in here, because that will be very useful if there are bugs, not to have to deal with it in the DOM. So what this is going to do is there's no IDs anymore. It's just going to check if you want to call this old item. And we'll call this new item. We're not going to get the IDs anymore. We're not doing that for right now. We're actually going to just use triple identity, because this algorithm works for that. So if they are the same, then move on. Otherwise, let's change this to, we'll change these indexes. So it's not list index, it's old index. And it's not, update index, it's new index. Move this old version here because we don't really care about that anymore. Okay. I was just changing the wrong thing down there, but that's fine. I'll just make the same fixes. Okay. So we get our new item, we get our old item, and then we're going to say, as long as there is the next item in the new list, and that item is equal to the old item, that means, or actually I'm going to do my patch here. It's going to look like this. Or I'll do patches. And instead of this, what we're going to do is we're going to add to patches a patch that is an insertion of this new item. But this looks wrong to me. Oh no, this is right. Okay. I thought it might be index +1, but it's not, because the item before index +1 was what was being inserted. It's nice that I already have this algorithm that I can just kind of adapt. This will make this go a lot faster. Okay, so old index, old list. So this is going to be if old is equal to the new item. That means we've removed something. So I'm going to push in another patch. And finally, in this case, if nothing was successful, we're going to essentially do this. Although I have map. Oh, we don't need that. We just need the new list slice from that point. If it's an array, which this will not be an array, but I think we do have the slice function, but I don't want to, I'll probably just use a normal array slice function, which hopefully should work on a CAN list. I think it does. That will be faster. So I'm just gonna do this. So we're gonna, what we want to do is go from the current index we're at to the end of the old list. We're gonna remove everything from the current index we're at on the old index to everything remaining in the old list. We're gonna replace that with all the remaining new items, which is gonna be, we're gonna use slice, and I'm just gonna steal it up here. I'm just gonna write it nicer. We're gonna do cat all those items. So we're gonna do slice dot call, and we're gonna use the new list, and then we're gonna call it with the new index. So everything after. So that's our patch. Does that make sense? What we're doing here?
No.
Okay, so yeah, make sure, please ask me questions when you get lost, because I will ramble and make it very hard to follow if you let me go too far.
Okay.
Okay, so do you get what these cases are doing?
Yeah, the cases are clear.
Okay, so this is the final case where you have just something it's not able to understand. So maybe you had like 1, 2, 3, and then you had 1, 2, and then you had like 5, 6, 7.
Okay.
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 So at this point, what you're going to do is you're just going to replace 3 with 5, 6, 7.
With okay, I see.
So what that's doing is the kind of old index would be, position 1 really, which is this position. So it's saying go from, basically that's the index from here to here. So like go from where you are in the old list to the end of the old list. We're going to remove all of those items. And then you're going to add all of these items, that's what this is doing.
Okay. And can you again repeat the format of the patch item?
The patch item is going to be it's just going to look like what you would normally pass as arguments to splice. So it's going to be each patch is going to be an array, and the first is going to be the index, how many items to remove, and then followed by items to add.
Index. And this is supposed to apply to the old array.
Yes, you would apply this to the old array.
Patch old array. Okay.
Does that make sense?
Yeah.
Okay. So that's why it's like when you want to remove an item, it's just the index and how many you want to remove, and then when you want to add an item, it's like that.
Okay.
Okay. So yeah, that is our patches, and then I'm going to return patches here. So this is if they were the same length, well then you're just going to return patches. This case right here is when you have, essentially this case right here is actually for when you have something like this actually, and then this case right here is when you have something like you just tacked on a bunch of things at the end. So you had something like this. This is just going to add. Presumably, this should always be 0. I don't know why there's. I would imagine this is always 0, but it's just adding the new items. I think I probably just copied and pasted. Yeah, I probably just copied and pasted this because it's the same logic. But I think actually that you're never going to be removing items. I think this argument could be 0, but it's not. But that's fine. So you can see here how like when you're adding items to the beginning of a list, if you're adding multiple, this is not going to help you. But if you're adding multiple items at the end, this actually would help you. eventually we should make it so that if you're adding multiple items at the beginning, it works just fine. But I'll leave that to you to add. How's that sound?
Yeah, that sounds great.
Do you get what I'm saying though? Like why?
Okay, so let me go through this again. So the first case is when we insert a single item. The second, if when we actually remove a single item. The third one is when we don't, like when none of the previous work.
Yeah.
And the last one for me looks like the same as the third one.
This one?
Yeah.
It is similar. It's just that you've hit the end of the while loop. So the while loop only continues until you reach either the end of the new list or the old list.
Mm-hmm.
So if you have a list that are of different lengths, it's eventually going to exit. And this just checks like, well, if their lengths were the actual same, then you are actually done. But if you had one that had more than the other, well, then you need to do the same cleanup.
Mm-hmm.
So actually, that's why it would not always be 0, because let's say you had these things up here, well, then you need to remove 5, 6, 7.
Okay. We need to remove 5, 6, 7. Mm-hmm.
So this would remove 5, 6, 7 because if this is the old list,
Mm-hmm.
your old index would be here. Let me make these a little bit different because maybe it's okay. So old index is going to be because it's the end of the while loop. Old index is going to be at 2.
2. Mm-hmm.
Right. So and then old index minus old list minus length minus old index is going to be 3. I think, right?
Mm-hmm.
5 minus 2 is 3, right? So what you're doing is you're saying I want a patch that's going to start at C and remove C, D, E.
3. Mm-hmm. Mm-hmm.
And then it's going to say if there's anything inside new list
Starting with
past
new index.
this index here, you're going to add those, but there aren't any.
Mm-hmm.
Right? So this is going to be so the patch is going to look like 3, 3 or 2, 3 or something like that, right? That's what the patch is going to look like.
Okay. Mm-hmm. Mm-hmm.
But let's say the opposite was true, and you got to the end of the while loop, and you had this. You were here, but now you had items that you were adding. Well, this is going to be your old index. You're still going to be starting at 2, but this is going to be 0 because there's nothing else remaining
Nothing
here.
else. Okay. Yeah.
But now you're going to be adding C, D, and E.
This is gonna be 0.
Because your slice, you're going to be going from your new list from the position at the end of the while loop.
Yeah. I got it.
That makes sense? So that's the final. That's why this is like cleanup for when you have arrays of different lengths.
Mm-hmm. Mm-hmm.
Now, what I was saying is this algorithm only handles single point insertion or single point removal, and it handles well if you have insertion or removal at the end of your list. It handles that efficiently as well.
Mm-hmm.
Right? But it doesn't handle, which I would like it to handle, insertion, single point insertion, like not single point, but multi-point insertion in one block anywhere in the list.
Uh-huh.
Right? The way to do that would be you'd have to like, if you ran through this case, well, what you would do is you would kind of check the next item. Right? So if you had, let's say I added, what we really want is the case where you have something like A, B, C, and then here you had, the next stage was A, D, E, B, C.
Mm-hmm.
Well, you would check A, and then you'd move on to the next thing. And then what you would do is you'd kind of set a point like, okay, well, here's the last point where I was. Now I'm going to check, does B match D? No, it doesn't. Does B match E? No, it doesn't. Does B match B? Yes, it does. Then I'm going to say, okay, I inserted these two.
Mm-hmm.
Right? I think this is doable in linear time, but I would have to do a little research. But that's the next thing. I'm not going to plan on doing that right now because I only care about single point insertion, which is more common. But multiple like items in a single point insertion and removal is also pretty common, and we should add that next.
Mm-hmm.
But this you can just at least this API for this diff supports that.
Mm-hmm.
If you get what I'm saying. So
yeah.
So this is a start. Now I'm going to load this in here. So make sure I load this. I need cursor. We need can util array diff.js. Here's my diff. And we're just going to see what this produces and see if, just check if it's kind of producing the right thing in here. What is it? So we're just going to check, make sure we have both an old and new list, and if we do, then we're going to run this diff with new list, old list. Is that the way I did it, or
Old list is the first, right?
yeah. Okay. Okay. So with that, let's see if let's see if we get what I was hoping for. All right, so here the patches look right, hopefully. So that's 3, and this one should be position 4. Yep, looks like it's it's getting the right patches to be added, so that I would just have to be adding things to the end of the
4.0 map, 5.0 map. Mm-hmm.
That's right. So, Chris, to catch you up, I have this diffing function that takes an old list and a new list, and it just looks for some basic minimal changes, and it returns a patches object, or the patches array that is an array of arrays, and each item, so there's patches, and each patch looks like the arguments you would pass to splice.
Cool.
Meaning, if you had A, B, C, and then had in the new list A, B, C, D, you should get something like that's an array of arrays. That's like what position would this be? 0, 1, 2. At position 2, you're not removing anything, but you are adding D.
Excellent. So can you show me the diffing part? How do you determine, how do you simply and easily determine the diffs without going through the list a gajillion times?
We only handle a subset of the possibilities. So we only handle single point removal or insertion.
Okay, so does that mean if the list is changed by more than one item, we don't even attempt this?
Yes.
Okay.
Except if it's at the end. We handle it nicely if it's at the end.
Oh, okay.
So if you remove a single item or add a single item, then it works just fine. Or you add items or remove items at the end. It will handle that just fine. But nowhere else. So eventually we need to go, this was something that I had already written for a different use case. Some point, someone will have to come back in and make this so it handles multiple insertion points, if that is indeed possible. It actually handles multiple insertion points, but I should say handles like a single ranged insertion. So if you added, like if
You added 3 items in the center of the list.
yes, exactly. We want that. Or I would say even more important than even the center will tend to be you've added things at the beginning. But yes, if it's possible to make that work. But I have a feeling
if like everything is the same up until the point that it's different, and then after the length of the new list, you start seeing the same values again in both lists. So you could kind of look ahead, right?
Yeah, I think what we say is if you can only have a single insertion at one time, then I think it can still be linear. You here's the case down here, right? Where if you had A, B, C, but now I'm inserting D and E inside. At this point, you stop and you keep walking forward until you find B. And if you never find B, and then if you never find B again, then too bad. You're just going to blow away the rest of you're just going to replace everything from B and C with this.
That's really cool. So we can like optimize, highly optimize quite a few situations with this, and this doesn't even look that complex.
No, you just have to, we need to play with this algorithm in here and make it a little bit smarter. Right now, yeah, but I just want to get it working, and then later we can fix the algorithm.
Right on. But this will make things so much better.
Yes, in some ways, this will make things a lot better. So I have it right now. I'm just doing the patch and just console log the patches, and they look to be getting the right thing. So now comes the tricky part where I need to. Now comes the tricky part where I need to somehow do all the node list stuff correctly. And that's what things turn into.
It's the messy bit, isn't it?
Yeah, it's the hardest part, yeah. So I can no longer, so update list was automatically calling teardown lists. We cannot do that anymore. At least teardown list we cannot have. In some ways it needs its like own code in here. What does old list look like in here? It's called. Okay, so first time update list is called, it's not called with a, it's just called with a new list. So there is no old list. So this teardown list, I think, is used other places. So this is going to get kind of weird for a little bit while I remind myself of how all of this works. This teardown list needs to be called a few different places, or at least, it looks like it's only called 2 places. That's actually not so bad. So there's one there where it's like, okay, it's called to really tear shit down because this DOM element has been removed. So hard tear down everything. That's why there's this full teardown. But otherwise, this old teardown, we really don't have to do as much.
Yeah, but full teardown just gets passed to remove. So we can kind of break this into 2 parts. Like one is, seriously, we need to unbind.
Yeah, we always need to unbind on the old list. That we always need to do. But we don't need to be doing this. So part of me thinks that what we should do is if there was a new list and an old list, that I'm just going to kind of write the Well, if torn down, we're going to get out of here. Actually, this should still go in the beginning. So if you're torn down, do nothing. Because it's possible the element was removed, but there's still, this event handling is still on it. Now, if you, we're going to do this. This is going to be a little tricky. Do we need this anymore? I thought we removed the need for this. Oh. Oh, that's why that's there. Okay. Okay. So if you have a new and old list, we're gonna do some things differently here. Hopefully this will work. I'm just rearranging. Okay, so we're going to set up our binding right away on the new list. And then if you had a old list, if you didn't have an old list, well, we're going to do the normal tear down and add and all of that stuff. But instead, if you have had an old list, and we're going to do this patching approach, we are going to unbind it, the old lists, and now comes the part where we're going to have to do the patching. And this is going to be where the hard part comes in. So we're going to have to, we're going to have to get in there and manually.
Is the patch order like correct? Because I mean, I would assume so, since you're going through it linearly.
Yeah, it should be.
Okay.
I'm going to add tests for this later, but what I should be able to do, well, there is no add, and fortunately, I don't think there's no possibility, oh, there are some adds and removes. So I have to always do a remove first, and then the add. So let's patches. Patch. Okay. So what we want to do is, I think we can actually call add and remove, which might be very nice. I'm hoping. I really think we can. And that will save us a lot of heartache, because add takes the index at which items were added. So what we can probably do, actually this might be not so bad at all. So what I can probably say is if patch 1. So this is like if we're removing something, because the 0, 1 is the index. This is the how many items you're removing.
Right.
Right? And what I could probably call is remove, similar to how this is doing it, but this will be, I think this is the index. Let me check what remove is called with. Event, the number, the items to remove, which I think just the length is all that matters. Where they are, I don't know what those options are, but I don't think we really need them. During teardown. Okay, so yeah, we don't care about that. Maybe we do. I don't know. We'll see. Well, let me see. what were we calling it with before? Oh, just the full teardown, but this is true, so we should do that. Okay, so true, but this will not be part of full teardown. So we are going to, this will not be here. We are going to remove as many items as were in the patch. That should just be it. And then if patch length greater than 2, that means we're adding items. So now I'm going to just do an add. And should just be the items that I'm adding, the index. Oh, no, wrong
How
thing.
does remove know where to start removing?
I passed the index. Didn't I?
I
Maybe I forgot to. Oh, here. Thank you.
Mhm.
So here, we're going to add items here, and then we're going to pass the number of items. I could change this to be, instead of an array, I might actually change this to be a, because then I don't have to do this slice call. You know what I mean?
Oh,
So
yeah.
I'll probably change it to patch dot like items or something like that.
Yeah, that makes sense.
But I want to, at least this way it should work, right?
Yeah, it looks correct.
This would be very, very, I would be very happy if it's as simple as this. I think I need to add this though. Yeah. Okay. I need to add that temporarily. So I can just do this like this. I think. This is, I don't know, it's a stupid bug, but
This is related to like if you're batching the list.
yeah, exactly.
Really,
Really what needs to happen is this kind of code needs to get cleaned up, because this code was initially written before after previous events was there. So it had a kind of a different method that was very similar to after previous event that involved setting these kind of flags. But now really can batch after previous events. That's what should really be doing the binding and the unbinding. It should be happening in here, because you shouldn't be binding until batch after previous events, because you've already handled everything. So that's when the binding should actually be taking place. But whatevs, I'm not going to fix that today. I just want to kind of see that this works. I always will do cleanup on my own. I don't need a partner to do that. So, okay, we don't need this anymore, probably. So there, if you didn't have anything before, you're just redoing everything. You're just redoing everything, and then otherwise, if you had an old list, you're going to do a diff, and then you're going to do the appropriate patches. Groovy. All right, well, let's see if this works. This would be really nice. There's no way this works, but
yeah.
Well, it worked. Now let's see if it works as fast. Like, it should work a bazillion times faster than the old one. Let's bring it to 100. Stash, benchmark, ABC, index HTML. Let's change this to 100 again. And it should go like gangbusters. Boom.
Whoa. Nice.
Cool. Very cool.
Damn, do we get some numbers on that? Other than like the visual difference?
Huh?
Do we like have a timer on that so we can see like the percentage increase in speed?
I can put one. So takes about a second. And this is including all the time like actually dispatching synthetic events and everything like that. So it takes about a second to add each one individually. And then before, I'm sure this is going to be a gazillion times slower. We should just have to, we just did false here. Hopefully do the same behavior.
Ridiculous. Holy shit. Don't crash, don't crash, don't crash.
So
Wow.
23 times faster when you're dealing with 100 lit. Now again, this is because, you know, if you were 1,000, it would be, we've changed it from n squared to n.
Yeah,
So
yeah, I get it.
it's not, you can't even say one is, it's not even times faster anymore. You can't say it's like we doubled the performance because,
That would be linear, right?
well, yeah, that assumes like you're comparing to linear performance. Yeah. We've done far better than that. If you have 1,000 items, if you had we're adding 1,000 items, who knows if this would ever complete? Right? It would probably crash the browser, but or just like freeze the browser. But now it goes much faster. So,
damn, shall we even finish Can Derive?
well, actually, this got me thinking. I mean, yes, Can Derive is going to be a similar type of performance improvement, though.
Okay, cool.
Right, because Can Derive is going to be logarithmic.
Mm-hmm.
So where it's going to be a similar kind of thing. Where like before, if you had 100 items, it might take 10,000, units of iteration, right? Mm-hmm. Now it takes 100 items of iteration, and if Can Derive comes in, then it takes 10 units of iteration.
Yeah. Wow. Shit.
So, yeah, it's better. Now this is, of course, like you could turn on batching and all of this goes away. Like if we had batched the insertion of these items, then this problem doesn't exist because the batching will wait till the end of all the items have been inserted.
Right.
And then just do everything based upon that last list. But you don't want to have to force people to batch everything.
Say that again?
Well, you don't want to have to batch everything, right? It's nice if it works fast without having to batch.
Sure.
So, and it doesn't replace the whole list, right? So this is still, even if you were batching, this would still replace the whole list. You just wouldn't be replacing the list.
And square.
You would just write it out 100. You would write the 100th out once, and that would be it. But if you wrote then after the batch just a single item, well, you'd still be writing 101 new LIs to the page, which is really bad. So this improves. This is different. Like, so for your thing with Can Derive, I would think that a mapping. That's actually an interesting question. Like, Can Derive. Yeah, no, so this, if you're adding a single item, is going to loop through and make one DOM modification, right? Mm-hmm. Yours would presumably do the same thing. This is going to be linear. Okay, so Can Derive is less important now
actually.
Yeah, yeah.
It's less important because, well, can derive is going to allow us logarithmic time to figure out which items to add and remove, where this is going to do it in linear time.
Right.
But this is only so smart.
One manipulation.
But this can also is only so smart. So if I add a single item, or if I changed, let's say, like, I don't know, I think, yeah.
If Andrive will be able to handle a wider array of modifications efficiently.
Yeah,
This
exactly.
is optimized for a few specific cases.
Yeah, I think this is like a big subset of those cases, but not all of them. For sure.
Right.
So
Yes.
will be good.
And we'll get this for maps and groups too.
Yeah.
Once
But that's
it's
the
all
thing.
set up.
This is one that I said is like, in terms of amount of time it takes. I just did this in about like an hour and a half. There's a lot more to do for testing. In terms of time and benefit, this is actually really useful.
Sure, totally.
Nice, quick win.
Return on investment is great there.
Yeah. Okay. Cool. So
Awesome.
I'm gonna clean it up and document it and add some tests. And
All right, well, great.
thanks for joining me.
Watching you, Justin, later.
All right. Thanks. Bye.